Alright, your homework help for section 10.5 day 1 is going to deal or consist of 3 problems. The first problem that we are going to take a look at is kind of like problems 3 and 5 that you have to do. It's kind of confusing in how they word it, so this is a good problem to actually read through a few times so that you can figure out what it is that they are looking for. It says the x prime y prime coordinate system has been rotated 60 degrees from the xy coordinate system. The coordinates of the point in the xy coordinate system are 3, 1. Find the point on the rotated coordinate system. So we'll get back and we'll do that one. The second thing we'll do is we'll actually run through and do the rotating and eliminating the axes, or kind of idea. So it's going to ask you to rotate the axes to eliminate the xy term, write the resulting equation in standard form, and then sketch its graph. And then we'll do another one where we rotate the axes to eliminate the xy term, write the equation in standard form, and sketch its graph. So let's start by taking a look at that first one. Like I said, this is like problems 3 and 5, I believe it is, that you have to do in the homework. What this is saying is that you have your normal XY system, like we always have. And then we have the rotated system. They said it's been rotated 60 degrees. So something like this, where this is x prime, this is y prime. And they're giving you the point 3, 1. And they want to know what are the coordinates if you took that point and rotated it 60 degrees, what would the coordinates be here? That's what it's asking. So that's the idea behind it. Now, the bigger picture is I need to know, what does that mean? What do I do? Well, that's where those two little equations came in, where we had x was equal to x prime times the cosine of theta minus y prime times the sine of theta, and y was equal to x prime times the sine of theta plus y prime times the cosine of theta. That's where those two little substitutions come in. They're telling me x and y, that's the 3 and the 1. I don't know x prime, y prime, that's what I'm trying to figure out, but I can figure out what the cosine and sine of 60 degrees is. So that's the idea. X is 3 is equal to the cosine of 60 degrees is 1/2 times x prime minus the sine of 60 degrees is square root of 3 over 2 times y prime. And then my y equation or substitution would be 1 is equal to, it's now the sine of 60 degrees, and the sine of 60 degrees we said was the square root of 3 over 2 x prime, plus now the cosine of 60 degrees we said was 1/2 y prime. And they are asking you to solve that system. And it looks messy because you see the radicals in there, but realistically it's no different than what you would do if I gave you this. If I gave you that system and said solve it, whatever you would do to this, you should be doing to that. If you don't know how to solve that, then we have a little bit of a problem, but you might want to go back and look at chapter 7. For example, a lot of you might say, well, multiply everything by 4 so I can cancel the y's, or multiply by -2 so I can cancel the x's. Same idea. Now, if you want to, might not be a bad idea. You notice that all these denominators have 2. I could multiply everything by 2 so I don't have to deal with any denominators. So I could say that 6 is equal to 1x prime minus the square root of 3y prime, and 2 is equal to square root of 3x prime plus 1y prime. So you could easily do that if you want to. I normally don't, but that actually kind of makes sense. Alright, so what do I need to do? Well, like I said up here, why would I multiply by 4? Because I would be trying to cancel the y's. Well, let's look down here. What can I cancel? Let's look at the y's. Let's say I want to cancel those. What would I need to do to that y? I would need to multiply it by square root of 3. I've already got a negative square root of 3. Multiply it by square root of 3, they'll cancel. So doing that, leave the top equation alone. That's going to give me 2 square roots of 3 is equal to square root of 3, and square root of 3 gives me just 3 x prime plus square root of 3 y prime. And now those, of course, will add together to cancel. This is going to give you 4x prime is equal to, not like terms, I can't actually add those together, so it's just 6 plus 2 square roots of 3. And what would you do to solve for x? Of course, you would divide by 4. So I would divide both sides by 4, and then I would most likely simplify that. So I would say that it's 3 over 2 plus square root of 3 over 2. And there is x prime. And then how do you find y prime? Well, what if I told you that this system or this one if you want to use this one. Well, what if I told you x prime was 1? You would go plug it in here and then you would solve. Well, you can plug this in here and solve, or like you could do here, I could multiply by -2 now and try to cancel the x's. So if you want, maybe come back up here and this time multiply the top equation by -square root of 3, and then these would cancel. So if I do that, that's going to give me -6 square roots of 3 is equal to -square root of 3 x prime plus 3 y prime. The bottom equation, I'm leaving it alone. It's 2 is equal to positive square root of 3 x prime plus y prime. They cancel. I get 4y prime is equal to, and again, they're not like terms, so just like the other one, I end up with 2 minus 6 square roots of 3. Again, I would divide both sides by 4, or whatever the case may be. And again, if you can break it apart and simplify, do that. So I would say that y prime is equal to 1/2 minus 3 square roots of 3 over 2. And since they have the same denominator, you can easily do this if you preferred to write it like this. It's kind of up to you. If you can simplify when you break it apart, I would say do that. If they still have the same denominator, then probably go ahead and combine them back together again. And then this is a system of equations. You are trying to find the x, y value on a standard system for this. Well, what that is it's 3 plus square root of 3 over 2, comma, 1 minus 3 square roots of 3 over 2. And now you've got your point on the rotated axes. So that's what numbers 3 and 5 are looking for. All right, on to the other problems where you have kind of all that work that you have to show, and this will take some time to get used to. One of those things where it's a lot of work, but once you get the hang of it, it's not so bad. It's just there's a lot of room for little errors, but you'll catch on to this. All right, so it says rotate the axes to eliminate the xy term. So looking back at our formulas, to start with, you want to find the angle of rotation, sort of. So you're going to say this. You're going to say that the cotangent of 2 theta is equal to, remember the handy little formula, is a minus c over b. Well, a is the number in front of x squared. I don't have one, so it's 0. Minus c is the number in front of y squared. I don't have one, so it's 0, divided by b, which is the number in front of the xy term, which is 1. So I end up with 0. It's cotangent. So remember that this is x over y right now. So think on your unit circle, where do you have a point of 0, 1? And of course you have a point of 0, 1 here at pi over 2. What that means is that the cotangent of 2 theta is equal to 0, which means if I did the, so here, let me write this. If I did the cotangent inverse and kind of got rid of this, I'm saying that 2 theta is equal to pi over 2. And that means theta is equal to pi over 4. That is my angle of rotation. Think about if it does make sense. If you plug pi over 4 back in here, you'd have to multiply it by 2. That would give you pi over 2. The cotangent of pi over 2 is 0 divided by 1, which is 0. Now, we'll run into this mostly on day 1, where you always have pi over 4. Now, what that tells you to do after you figure out that angle of rotation is now you're going to make your substitutions. So you're going to say x is equal to x prime times the cosine of pi over 4 minus y prime times the sine of pi over 4. And y is equal to x prime times the sine of pi over 4 plus y prime times the cosine of pi over 4. And then you're going to have to go ahead and figure out what the sine and cosine are, and lucky for this one, they're square root of 2 over 2 for everything. So it's square root of 2 over 2 x prime minus square root of 2 over 2 y prime. There's the x substitution. The y substitution is also going to be, well, it's not also, it's square root of 2 over 2 x prime plus square root of 2 over 2 y prime. And like I said, I think all of the ones that we do for day 1, you end up with that substitution. That won't happen in day 2 and day 3, so it'll start to get a little more complicated. All right, the idea now is you go back to the original equation, and wherever you see x, you plug this in instead. Wherever you see a y, you plug that in instead, and then multiply everything together. So instead of saying x times y, I'm going to say it's x, which is really square root of 2 over 2 x prime, minus the square root of 2 over 2 y prime. There's x, times y. Here's the y substitution. It's square root of 2 over 2 x prime plus the square root of 2 over 2 y prime. So there's x times y, and now I still have minus 2 equals 0. So all I've done is I've gotten rid of my regular x's and y's, and I've changed them into the x prime y prime system. Alright, now my job is to multiply all this together. So it's foiling. These are conjugates, so I shouldn't have to worry about the insides and outsides. Think about this when you multiply it. Look at the numerator. Square root of 2 should give you 2. Look at the denominator. 2 times 2 should give you 4. That's going to simplify to 1/2 x prime squared. And because of the prime and putting parentheses in the square like we did in class, you can stop writing the x primes or y primes when you start multiplying stuff out. Insides, outsides, since these are conjugates, will cancel. When you multiply the last together, pay attention to sign. It's minus 2 over 4, or 1/2, y squared. Minus 2 equals 0. Or I can kind of see that this is a hyperbola. I've got two squared terms, one positive, one negative. I know that this has to equal 1, so I would just come over here and say, let's divide everything by 2. And remember, multiplying by the reciprocal, this is going to give you x squared over 4 minus y squared over 4 equals 1. And technically, it's not x, it's actually x prime squared and y prime squared, but you don't have to put the primes in there. Just know that that's what it is. Alright, so for that one, a little easier. When you multiply these together, any term that you have left, which we only had 3 terms, should not have x and y in them, or if you do have x and y, they should cancel out, which you'll see happens in the last problem that we do. Alright, now for sketching it. This is going to be a very rough sketch, and this is all that we are ever going to do. This is my x, y coordinate system like we're used to seeing. We said that we were rotating it pi over 4, which is 45 degrees, so I'm just going to put a line in here at 45 degrees. And I'm basically going to pretend like I tilt it here. This is now my x-axis and my y-axis. And then think about what you would do to graph this. You would find the center like we did in 10.4. Well, the center is 0, 0. So on your tilted axes, so maybe just look at it like this, there's my center. Underneath the x prime is a 4. Take the square root of that, you would get 2. So you'd move 2 tick marks to the right, 2 tick marks to the left, and put points. Under your y term, you've got a 4. Square root of that is 2, so you're going to go up and down 2. 1, 2, 1, 2. And there are your 4 points. It's a hyperbola, so you need to draw a rectangle around that. Now remember, you're looking at it like this, so when you draw your rectangle is going to look like this. Realistically, this is what the graph is looking like, but it's going to be a lot easier if you look at it at the angle like this. Now, why did we draw in the rectangle? Because we have asymptotes. So there's actually an asymptote going from corner to corner. Now, if we did this exactly accurate, it should be right on the x and y axis, and yeah, we're pretty close here. And now, looking back at my equation, it was the x prime, or x term, that was positive, so this should be opening to the right and left. So using these asymptotes, there's one vertice, it's going to look something like this. Here's the other vertice, it's going to look something like that. And so now if you want to know what this equation actually looks like for a graph, it looks like that, where it's a hyperbola opening kind of at a diagonal up and to the right, down and to the left. Alright, like I said, it's tricky, it's going to take some time to get used to. Most important part I would say right now, make sure that you know how to work this thing. Be able to get to this number. Like I said, today this is probably always going to happen, but make sure that you can get there. As soon as you see that this is equal to 0, you can just immediately say it's pi over 4. Go to those substitutions and then start plugging stuff in. If you get kind of caught up in here, that's something I can help you out with, and eventually that'll kind of click with you. Just don't get frustrated. You got to make sure that you try this kind of over and over again. Go back and see if you can't find the mistake if possible. Alright, so same type of problem. Going to start by finding the angle of rotation. So cotangent of 2 theta is equal to A, which is 1 here, minus C, which is 1, divided by B, which is 2. And of course, again, I get 0. So I know that theta, without showing all the work, is eventually going to be pi over 4. Again, if you look at your unit circle, in terms of where is the cotangent equal to 0, you'll see tomorrow but we always say that the y value is positive. So even if this was a negative 2 and you'd say, well, no, it's actually down here, that's not the case. We're kind of restricted to be up in the top 2 quadrants. So I know that this is at pi over 2. Well, that means that 2 theta has to equal pi over 2, which means theta equals pi over 4. All right, now that I've got this, I can immediately go to my substitutions, and since I know them from the last problem, I'm going to say x is equal to square root of 2 over 2 x prime, or that's x prime times the cosine of pi over 4. I would probably suggest for all of your homework you write this out until you kind of have that down. Once you've got that down in terms of cosine angle minus y prime sine of the angle, once you've got that down, then you can maybe jump to doing this, but I would say get in the habit of doing this all the time. It'll be helpful for you, especially when you get something that's not pi over 4. All right, minus square root of 2 over 2 y prime. There's the x substitution. The y substitution is the square root of 2 over 2 x prime plus the square root of 2 over 2 y prime. All right, and then there's the equation. You see there's a little bit more going on here. So now I have to write x squared, so this squared. So it's square root of 2 over 2 x prime minus square root of 2 over 2 y prime, quantity squared, there's x squared, plus 2 times x, which is square root of 2 over 2 x prime, minus square root of 2 over 2 y prime, there's x, times y, which up here substitution says that's square root of 2 over 2 x prime plus square root of 2 over 2 y prime. So there's 2xy, and now I still have plus y squared, so square root of 2 over 2 x prime plus square root of 2 over 2 y prime squared equals 20. So using my substitutions, I have now rewritten this equation like this, where this is x, xy, y. And now my job is to multiply this all out so I don't have parentheses. And it's at this step where I'm going to stop writing the primes, even though I should, just so I don't have to do all these parentheses. Now, if this is hard for you to see, this being squared, then I suggest you write it out. For some of us, it's not a big deal to square this in our heads and see how it works out. But if you can't see it, then please write out the 2 sets of parentheses, at least at the beginning, because these are not conjugates. They are not going to cancel out. So when I multiply the first together, I get 2 over 4, or 1/2 x prime squared. I'm going to leave the prime off. The insides and outsides are exactly the same. So when I do the insides, I get 2 over 4, negative 2 over 4. The outsides is also negative 2 over 4. Negative 2 over 4, negative 2 over 4 gives me negative 1x y. Multiplying the last, they're both negative, so it's positive 2 over 4 y squared, or 1/2 y squared. So all of that squared is that right there. Again, if you can't see that, please write it out and multiply. Really what you're doing is you're squaring that term, you're multiplying these two together and then doubling it and then squaring that term. Here, these are conjugates. I'm going to ignore the 2 for right now, so plus 2 times. Multiplying the first together, I get 2 over 4, or 1/2 x squared. Insides and outsides cancel. The last will give me a negative, again, pay attention to signs, it's important, 2 over 4, or 1/2 y squared. There's so much room for little errors that you really got to be careful with signs and multiplying your radicals and so on. Now I'm going to FOIL this one out, and again that means squaring this, so that would give me 2 over 4, or 1/2 x squared. It would mean multiplying these together, which would give me 2 over 4, and then doubling it, so 4 over 4, or 1 xy. And then squaring the last one would give me 1/2, or 2/4 y squared equals 20. Now these two things are basically the same, so these two things should basically be the same other than this. Noticing all those little things will help you a lot. Last thing I'm going to do before I start doing anything else is I'm going to distribute and get rid of all these parentheses. So nothing to do here. It's 1/2 x squared minus xy plus 1/2 y squared. Going to distribute the 2, so that's going to give me a positive 1x squared, a negative 1y squared, and I really don't need parentheses there, so I'll just drop those off. 1/2 x squared plus xy plus 1/2 y squared is equal to 20. So kind of backing up, make sure that you can get these substitutions. you get them plugged in correctly, and then this is where you got to be careful and go slow. Once you have all of this done, remember what you're trying to do. You are trying to eliminate the XY term, meaning if you have an XY term left in this thing after you've done multiplying it all out, they need to cancel. So if you look, these two added together will cancel. That means I've probably done this correctly. If they don't cancel, that means either your substitutions are wrong, your angle is wrong, or you've simply multiplied something together wrong. And that's where it gets frustrating, because that's a lot of work to have to try to sift through to figure out what you did. But it's great practice. If you can find your own mistake, you'll be less likely to make it in the future. All right, so now let's combine like terms. I've got 1/2 x squared here. I've got 1x squared, 1/2 x squared. So there's 1 plus 1, or 2x squared. The y squareds, I've got 1/2, which gives me 1, minus 1 completely disappears. So I really end up with 2x squared is equal to 20. Unusual to have the y squareds cancel, but that's fine. Since I don't have a y squared in here, I'm not looking at a hyperbola, I'm not looking at an ellipse, I'm not looking at a circle. I'm going to divide both sides by 2 to get 10, and then I can just take the square root of both sides and get plus or minus the square root of 10. I'm actually looking at two lines. I have x equals positive square root of 10, which is a vertical line, and x equals negative square root of 10, which is also a vertical line. So in terms of the graphing, here's my xy system, my normal one. Again, we're rotating 45 degrees, so just do the best you can at approximating 45-degree angle. There's the x prime, y prime system. And then square root of 10, I know 3 squared is 9, 4 squared is 16. It's somewhere between 3 and 4, so if you put tick marks on here, you would go over and say 1, 2, 3. It's somewhere between 3 and 4, maybe here. And 1, 2, 3, somewhere between 3 and 4, say here. And these are just vertical lines. So this is what your graph would actually look like. Just two vertical lines if you look at it at the angle, but yours are at a diagonal. Alright, that is homework help for 10.5. Again, if you need to go back and maybe re-look through the process and what we did here and maybe try to do this on your own, it's an important process that you will get. It's just easy to make mistakes and it gets frustrating early, so try not to get yourself frustrated. That's why we're going to spend 3 days on it, just to get the practice.